Okay, so we're going to learn a couple new theorems and properties and things to use only when you have a certain type of triangle. Okay, so at the beginning of the chapter kind of focused on like proving any triangles are congruent, didn't matter what kind they were. We had all the methods, the side, 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 all that stuff. Okay.
So like, does there ever want to be like a triangle thing where like we use like scaling, like, or we just gonna be on isosceles?
Scaling's kind of different because they're kind of so many. There's no like they're all just different side lengths. You know, like these, since two are the same, it makes certain things happen. And equilaterals have all three the same, it makes certain things true. So scaling's kind of like its own little world. There's nothing really we can do with them.
Okay.
Okay? And then, of course, right triangles have a ton of stuff that happens with those. If you guys remember Pythagorean theorem, works with right triangles. The a squared plus b squared equals c squared formula. All the trig stuff, the sine, cosine, tangent. I don't know if you guys have really seen too much of that, but you will. A little bit this year and a lot more next year. A lot of that's with right triangles. Okay, so we'll kind of start it out with the theorem called the base angles theorem. Okay, and you can read it there. If two sides of a triangle are congruent, okay, then the angles opposite them are congruent. Okay, so what kind of triangle comes to mind when two sides are congruent?
Equilateral.
Could be, but for sure it's isosceles, and if all three are congruent, right? So, right, yeah, you're technically right. So isosceles with two sides congruent, if all three are congruent, equilateral. Okay, so this theorem here, we're going to prove it in a second. Okay, but I want to give you guys a little picture to kind of go along with the words. Okay, so it kind of says if two sides of a triangle are congruent. So if, let's just draw a little triangle here. So if two sides of a triangle are congruent, let's say those two sides are congruent. Okay, so that's like the if part. Then what do we know is true? So then those angles opposite them, so this is supposed to be the same triangle, looks terrible. Let's do a better one. Um, so then the angles opposite them, so which angles? Opposite those sides. The base angles, okay, so if you're looking like here, right, that side, the angle opposite it is the one all the way through the triangle. So this angle, and then for this side, the opposite angle is down here. It's the one all the way through. So those two bottom angles, or we call those the base angles. Okay. So not the top angle. Wait, I got two people talking to me at the same time. Go ahead. And then. Like if all three sides were congruent, you're saying? Then that would force the third angle to also be congruent. We'll talk about that later. That'd make it equilateral. Okay. Yeah, if it's isosceles, then the base angles will be the two that are the same. Exactly. Yep. Okay. And so notice this top angle up here. This is the one we didn't know is congruent. Maybe it is, maybe it's not. But the side opposite that is this bottom side. So we don't know if that's congruent to the others or not. It could be if they're all the same. But we're just saying if we know for sure these two, then we know these two. Okay? Yes, sir. Um, yeah, so what I'm kind of doing is this is actually just like the exact same triangle. So we're not like comparing it to another one. I'm just saying like if in any triangle you know two sides are congruent, then you know those two angles are also congruent, like in that same triangle. You see what I mean? Okay. So let's prove it. Okay, this is just kind of a demonstration or a little illustration of it, but let's prove it. Make sure you guys believe me. Okay, so here's a little picture we can use to prove it. So the base angle theorem. All right, so let's mark our picture. We got some givens, right? We got some sides congruent, wx, xy. Okay, it's a given. Wx equals xy was given. Okay, now here's where it gets a little different. We haven't done this yet in a proof, and you probably won't be expected to like do it on your own, but it's something that we can do and we'll probably get to. You can add things to a picture. Okay, what we're going to do to make this work, we're going to say let's construct or let's make some segment, call it xz. Let's put a point z there. Okay, and again, this will kind of come up more later, but what you can do is say construct xz. So we kind of drew it in there, we added it. To bisect wy. So we're like putting a segment in there, and we're also having the condition that it cuts wy in half. Okay, and then for the reason for that, let me see what they say. I forget how they word it. What are we doing there? Yeah, they didn't really. The book when they prove it, they did it as a paragraph proof, so they didn't really give a reason. So again, don't really worry about having a reason here. Just let's just say we did it. Okay, we drew this segment in. We wanted to bisect wy, so we know that it cuts. It's like the midpoint of wy. Okay, again, this is just to get the proof down. It's not something you'll have to do on your own. Right, you're not going to have to do this kind of thing. This is just something that can be done to prove a theorem, but I won't expect you guys to like do this yet. Like I said, for the reason, yeah, like the book proves it as in like a paragraph proof. So they didn't do like 2-column proof. So they didn't really give a reason, so I don't even know what to say really. But it's just like something we're going to do, and we're going to use that. Okay? Yes?
So like, are we gonna like do it the way you expect us to do it, or are we just gonna do this way? Like, are you gonna give some examples?
Yeah, the problems we're going to do, you won't have to like prove something like this.
Okay.
Okay, you're going to solve, we're going to solve some problems with it in a minute.
So this just show us like how to find out the answer.
This is like proving the theorem. And we're just going to be using the theorem. We don't have to prove it.
So we're gonna have 2-column proof.
Not of something like this. Exactly. You won't have to prove the theorem. You're going to use the theorem. Okay. We can use, you mean this step 2? Is that what you're asking? It can be used in other theorems, yep. Okay. Yes, sir. Sure. Call it whatever you want. All right. So yeah, when it comes up again, I haven't seen it for a while. That's why I can't think of how they would state the reason. But again, don't worry too much about that. What I want to get through is just proving this theorem. Okay. So how can we prove this theorem? Now that if that was in the picture, I think we kind of know enough. So z is the midpoint. Okay, that's true. And then say wz is equal to, yeah, and that's kind of what the bisect means. So let's just say, all right, wz then is equal to zy, and that's because of the bisector. You can say definition of bisector or something like that. Okay. So we drew that segment in there so that it would cut that wy in half. So that's what it did. Okay, so that's the definition of a bisector. All right, now we're trying to prove, so again, go back to the picture, the angles theorem that we had at the beginning. We were given the two sides are congruent. We want to prove that, we want to show that this and this are congruent. That's what the theorem said on the previous page, right? The base angles are congruent if the sides are congruent. So we don't know the angles yet. That's what we're trying to prove. How can we do that? Okay, we can go xz is congruent to itself right here. Reason? Reflexive. Okay. So now what do we have?
Side, side,
We have side, side, side. Okay. To the left triangle is congruent to the right triangle by side, side, side. So let me give it a little more space here.
they have triangles.
Now we can say the triangles are congruent, and let's name them appropriately. We can say WZX. So you kind of just pick an order to write the first one, and then make sure you write the second one where things line up. YZX. Okay. Reason? All right. So we got all three sides. We got congruent triangles. Do we have enough to say angle W is congruent to angle Y?
Yeah.
That was the newest thing from last section. That's everyone's favorite little CPCTC. Okay, we have congruent triangles. W and Y are corresponding angles. Okay, notice where they show up. They're both like the first one. They both line up in the corresponding spot. So angle W is congruent to angle Y by that CPCTC. Yeah, think of it. Corresponding parts, congruent triangles are congruent. Okay, there it is. There's our proof. All right, so remember the theorem said if the two sides are congruent, then the angles opposite them are congruent, right? That was the base angle theorem. Okay, what is the converse of a theorem? What is the converse of anything? What do we do? Flip the, okay, so what would it be for this specific problem? If the angles are congruent, I'm going to draw it with a picture. If the base angles are congruent, then we know the opposite sides are congruent. Okay, so it's just flipping the order. Okay. Now remember, originally it was if the sides are congruent, then the angles are congruent. This is just the converse. Flip the order.
What is that if the base angles are congruent
Yep.
and the
Then their opposite sides are congruent. Yep. So it's just the opposite order, and they're both true. They both work. I'm not going to prove this one, but they can both be used. Okay, and we are going to use them. Okay, so this is the converse of the base angle theorem. Also true, can be used in proofs, can be used in problems. Okay. Okay. Now there's one little extension to this. Okay. All right, and this is what's called a corollary. It's like you take a big theorem and you add a couple little details that like directly follow it. A corollary, corollary. It's like a small little theorem on its own, but it's like directly from the one we just did. It's like a continuation. Okay. So these are two separate things here. One and two. Two statements. Okay. Okay. All right, and I want to do this again with a picture because I think it's easy to see a little diagram. So if a triangle is equilateral,
Then three sides are equal. Yeah.
right, so this corollary is saying if it's equilateral, if all three sides are the same, then it will also be equiangular. Using the same kind of logic as we did before. If we know the sides are congruent, then we know the angles opposite them are congruent. All three of these are the same.
if a triangle is equilateral, then if
So in words, the wording is it is also equiangular. Okay, so do you see how that kind of directly follows the last theorem? The last theorem dealt with having two sides be the same and then those two angles were congruent. This is just extending it. If all three sides are the same, then all three angles will be the same. Okay? So equilateral and equiangular always happen at the same time. If a triangle is one, it's going to be the other. It's just the way that it works out. Okay? And then same thing with the second. This is like the converse of that. It's true also. If it's equiangular, then it is also equilateral. Okay, so this is like just a direct, a consequence or the next step from the previous theorem. And again, I think it helps to see these kind of in diagrams forms too. So if it's equiangular, that means what?
Then all angles are
All
equal.
the angles are equal. So if that's true,
That means all the sides are equal.
that's going to force all the sides to be congruent also. Exactly. Okay, so that is that. Those are the two little corollaries. And see, those only apply to equilateral and equiangular. Okay, still isosceles because they have two congruent sides, but these happen to have even more. They have all three. Okay, right. All right, so let's use these in a couple problems. This is like similar to what you guys are going to be doing in the homework tonight.
So if one is the other, if one is the other, why do they have two different words?
Okay, so let's think about this. So we got, there's kind of like three triangles on the board. I see there's the whole thing's one big triangle, and then like a left triangle and a right triangle. Okay, and then we have like some sides are congruent, and we know some things. So what can we start by doing? Okay, yes.
Well, since the sides are equal on one triangle,
Okay.
that means the other two have to be equal. And that's basically all you have to do is minus one.
Okay, you looking at this triangle here.
Yeah.
All right, we knew two of the sides were congruent. Okay, so this angle is x. So what's this one?
Divided by 2.
Well, hang on, just what is it?
65 equals.
It's also going to be x, right?
Yeah.
That's kind of what I'm getting at. So this angle is going to be x also because the sides opposite them, notice that. If those sides are congruent, those angles better be equal to each other.
2x equals
Now we can use the angle sum theorem, 180 in a triangle.
65.
Okay. The angles in that triangle add up to 180, so x plus 50 is 180. Okay, so I'm using base angle theorem and triangle angle sum. Okay, question?
How do you have three X's?
How do I have three x's?
Oh, never mind. Stupid.
All right, so
Then
wait,
angle.
let's just finish this one real quick. All right, 2x plus 50 is 180, right? Subtract the 50 from both sides. 2x is 130. So x is.
60.
All right, so we got x. All right. All right, so we got x. Now what?
Alright, from there, the angle next to x is alternate exterior.
Ooh.
Alright,
Uh,
on that one.
what do we have to know to use that? All those things.
That they're parallel.
We would have to have parallel lines. So I would avoid that.
No, not alternate exterior. Like,
Something else?
no, linear pairs. Something.
Yeah.
The one to the right of it is also one because the base angle is 3.
Let's be careful on that one. Look at, all right, so in this triangle, this angle is opposite that side, right? The angle opposite the other side we know is congruent is way up here.
Yeah, that's what I was saying.
Oh, this one's y.
Yeah.
Okay, I thought you were talking about the other one. So yeah, okay, so that one's y. Okay, I'll go there. That's, and now,
Y is 115 because 65 is 180.
okay, so here's what we can do. Yeah, now once we get one of these, we know this angle is 65 now. And I think we were trying to say this makes a linear pair with a 65-degree angle.
Yeah.
So that angle is 115. That's not y though. But that's 115.
I don't know why.
Okay, to get a 180 right here. Now can we say 115 plus y equals 180?
Yes.
All right, let's do that. 115 plus 2y is 180. Solve that for y. 2y is going to be 65 when I subtract the 115. Okay. Yeah, so I had this other triangle here, right? This one. And it was y, y, and 115.
So it's 32 plus 60.
So y is 32 and a half degrees. Okay. It can be decimal, yeah. Okay. Okay, so a lot going on in this one too. Okay, what do we got? So this triangle here, all three angles are equal, right? And if they add up to 180, what do they all got to be?
60.
60. Okay, so equilateral triangle, they're all going to be 60. Okay, 60 plus 60 plus 60, that's the only way to get 180 and have them all be the same. Okay, 180 divided by 3. Right? Okay, Charles.
Okay. Those two, the angle above 50, 60 plus 50 is 110,
Okay.
and 180 minus 110 is 70.
Okay, so you're finding this angle here
Yeah, that's 70.
using the fact that these three make a linear pair?
Yep.
Okay, perfect. That's something we can use. They form a straight line. So the two at the 50 and 60 is 110. This must be
70.
70. Okay, perfect. That's a good piece that we could probably use. Okay. Let me get someone else who hasn't talked. Miles.
X equals 70.
Is X going to be 70? Is it?
No.
Maybe. Let's see. So we know, let's see what we know. We know this angle here must be the same as this up top angle because those sides are congruent. So we know this one's 70. Now I think we can get X, right? Now can we get X?
That's 40.
Okay, because the middle triangle needs to add up to 180. So
40.
X is going to be 40 to make these. So that's a 40-degree angle because, again, the middle triangle has an angle sum of 180. Okay? And Adriana? Okay. Okay, good. Again, so get in the habit of noticing. Here's an opposite. So the congruent side, its opposite angle is also 50. And now we can find y. We got another triangle. We know two angles. The third one has to add up to 180. We got an 80-degree angle for y. Okay, so there's our two answers. X was 40 and y is 80. Okay?